one of the rules that some people find attractive is the indifference principle. The indifference principle, John Maynard Keynes says, the principle of indifference asserts that if there's no known reason for predicating of our subject one rather than another of several alternatives, then relatively to such knowledge, the assertions of each of these alternatives have an equal probability. Okay, so suppose you're attracted to such a principle of indifference. The fundamental problem with the principle is Bertrand's paradox. So suppose we have a factory that produces square picture frames from 1 to 3 feet in width. You want to know what the probability is that a randomly chosen product off of the assembly line is greater than 2 feet in width. And there it looks like you divided the space of possibilities equally, since the space of possibilities runs from 1 to 3, and you're asking about the upper half of that. If we apply the principle of indifference, it looks like we should get a probability that a randomly chosen product will be greater than 2 feet in width. But suppose you then reframe the question in terms of the square footage of the frame, asking whether it has a square footage greater than 4 square feet. We apply the principle of indifference again, but now the range runs from 1 to 9, because a 1 foot square frame will be 1 square feet, and a 3 foot square would be 9 square feet. So now you've got a range from 1 to 9, which is 8 units in width. And we're asking about whether it's in the top 5. So we get an answer of 5 over 8, or 0.625. Now that is strange, and it shows that there's a problem for the principle of indifference, because you have to be able to specify what the exact description of the problem is supposed to be before you can apply the principle. This is an example that shows questions, logically equivalent questions, can be answered differently when you apply the principle of indifference.